All right. Good morning, good afternoon, good evening, everyone, depending on from where you're joining in. Welcome to the session on DevSecOps, what, why, and how. I'll start with a quick introduction of myself. I'm Director, Not So Secure Global Services. My name is Anant Srivastav. I started my career as a system administrator, then did a bit of work in development, and then for past 6 to 7 years, I've been involved with information security as a focus area. I've been trainer and speaker at a bunch of different conferences, including Black Hat, Malcon, RootCon, FruxCon, bunch of others. I like doing open source work, so there are a couple of projects in which I am the project owner. And I also like to contribute to various open source communities. The handle that I use on all of my social platforms is Anantshri, ANANTSHRI, and the website is available. Now, quickly transitioning to the topic at hand, the agenda that we are going to cover today is what is DevSecOps, why do we need DevSecOps, how do we go about doing DevSecOps, how to integrate security in DevOps pipeline, what kind of tools are we looking at. We've got some sample implementations, so we'll talk about those sample implementations both on-prem and cloud native. And then there are some case studies that we are going to briefly touch base on. So a quick disclaimer before I get started with doing a lot of these things. We're talking about integrating security in DevOps pipeline, which basically means we'll be talking about a lot of tools. I am not specifically endorsing a particular tool. I'm not saying that you should use this particular tool only. What you need to understand is these are the tools that worked for me. However, every environment is different. You need to take the tools that you want to use and you need to test and validate them before you go about implementing them. Now, what is DevSecOps? We keep hearing these terms. What exactly is DevSecOps? The idea is to have a secure by default state. How can you achieve that? When you integrate security via tools, when you build a culture where security is a part of the culture, and when you promote cross-skilling. So not just dev and ops as one team and security as another, but rather both teams learning each other's skill set and having a combined team moving forward. Now, why do we need DevSecOps? DevOps has been moving at a rapid pace. Whereas security, if you look at it, still asks you that, hey, if you want to do a security assessment, I'm going to need 5 days to do the assessment on a web application. You don't have that much time. The things move at such a rapid pace that you may have more than 20, more than 40 deployments in a single day. DevOps is at that rapid pace, whereas security just can't keep up. So DevSecOps allows you to integrate security into the existing processes. The idea is to have a smoother and scalable process, manage security at a rapid pace, and basically integrate security as part of the process. That's the only way to ensure safe, or rather ensure safety going forward. Now, if you look at the conventional way of doing security within a DevOps, this is how the DevOps cycle would go. You'd start with a developer developing a software, pushing it to a code repository, a build getting processed via CI/CD server, then something getting deployed to staging or QA. If everything works fine, it goes to production, and then we have some monitoring coupled with it. And along with this, there is no security stage here. Once everything is done, then some security tests might be conducted towards the end of the engagement. Now, this is where things change, and with DevSecOps, you can do something better. Let's say we added one step when we are building the project. We added a step so that we can do automated source code review. Assume you found one SQL injection at that point. That SQL injection spot at the build time would result in far fewer man days because the developer has just recently pushed the code and the build was automatically generated and they got the feedback. They can immediately work on it. Whereas if you follow through the entire process, staging or production, once it is deployed there, that may be too long for a developer. The developer might have moved on to a new target. So not the optimal utilization of resources. And this, the process of moving security from here to the left side is called shifting left. This is a term that you would keep hearing a lot, that we should shift left. We should shift the security towards the left. This is what it means. You shift the security from being on the extreme right and pull in all the checks as close to the developer as possible. Now, how do we go about doing DevSecOps? DevSecOps is automation at one part, but there's a large chunk of cultural changes that are also required. You need to integrate security tools. However, just by integration, it's not going to help. You need to have a cultural change that will embrace DevSecOps. So we're going to focus on the integration of security tools first, and then we'll talk about the cultural changes. Now, what we've done here is we've taken a typical DevOps process and we've added security checks at each of those levels. And you can see for each of these sections, there are multiple checks, multiple security tools or type of tools that can actually be used. So a conventional DevOps pipeline, which is what we've shown right at the top, can actually get converted into a DevSecOps pipeline where you see multiple stages in here. So let's quickly touch base on what these stages are. The first stage that I wanted to talk about is outside of the pipeline. This stage is where you are installing checks at the developer workstation. So pre-commit hook is basically a wrapper which allows you to perform some basic checks even before a commit is made. Which means as soon as the developer has written the code and they try to commit the code, this pre-commit hook is going to come into picture, will perform some checks, and may block the commit. Where this would be helpful, this is a pure regex based approach, which means it'll be helpful if you have common patterns. Like for example, AWS secret key. If this kind of sequence is found and there's a value associated with it, that needs to be stopped from going into production. Other SSH keys, or let's say your private PGP keys, anything which is private in nature, anything which, or rather anything which can be easily identified using a regular expression patterns, that can be detected via the pre-commit hooks, and that can be prevented from going into production and polluting the Git logs. Now, that was if some mistake was made, we can stop it. The second approach is by installing security plugins in your integrated development environment. Now, these plugins are not going to be extensive. They are not going to be as extensive as a source code review tool. However, what they do provide you is a quick check to stop silly security blunders. Like for example, using MD5 for your hashing. That will be immediately spotted. Anything which is very, very quick to spot via basic pattern matching, that can be done via IDE Security Plugins. However, the thing that you need to keep in mind, both IDE Security Plugins and pre-commit hooks are part of the developer workstation, which means if I'm a developer and I have administrative rights over my development workstation, I would have the rights to bypass these two. I can uninstall the plugin, or I can ignore the plugin. I can uninstall the pre-commit hook. So good to have, but you can't enforce them. Now, I talked about secrets should not actually go in the code, but where should they actually go? So you should have a secret management system. That's where you need to store the secrets. And then you need to have a process of retrieving the secret from the security management or secrets management software. Now, this is before the pipeline started. What happens when the pipeline starts, or what kind of checks we can do? We'll get to that now. The first point that I want to talk about is software composition analysis. And this is where we need to start understanding our development policies right now. If you look at a project lifecycle, you would realize that we are using a vast majority of frameworks or modules from third-party softwares. Now, these softwares are not built by us. And these softwares or modules are third-party in nature, which means they may have different priorities. They may not want to update the software. They may not want to bother about security issues. However, we might actually be bothered about them. Any of the modern sane applications, or rather the application frameworks, would have some sort of module systems, be it pip, npm, gems, goget, perl cpan, php packager, or bunch of different options. Now, on an average, the modules constitute of around 80% of our code. We only write 20% of our code. The remaining thing all comes from these modules or the frameworks. Now, these frameworks, these modules will have vulnerabilities which will not be directly spotted, and hence software composition analysis, which will look at these third parties and will tell you how many of them are outdated, how many of them are vulnerable. Now, once we have looked at third-party sources, we now need to focus on our own code, which means we will start with static analysis, which is a white box approach to source code review. Here, again, we are going to weed out low-hanging fruits. The important bit to understand here is, and this is something that I've seen at a lot of different places, you would have a lot of tools claiming to provide you good results. However, people generally use the tool once, get a very thick report, and then forget about that tool. The problem with that approach is most of the tools are configured with generic settings. You need to try multiple times, tweak the configurations to reach a point where you're getting good results. If that is not done, you would simply be using too many tools and you would not get anything out of them. Now, let's say we looked at static analysis, found something. What next? The next step comes with dynamic analysis security testing. A part of the tools, or rather part of the vulnerabilities, would not be visible if we have not performed a dynamic analysis over the system. Plus, application logical flaws will be hard to spot in SAST environment, and hence it is better to run a DAST tool and work with them. So let's say we've run the DAST tool also. What next? The next part is we need to ensure that your infrastructure is not kept at the mercy of a administrator, but rather your infrastructure should be documented in infrastructure as code format. Nowadays, we rely a lot on Docker and Kubernetes kind of environments, which basically means we are leveraging Docker images. Now, these images basically means is again like a third-party software. So the environment is as secure as these third parties. So you need to ensure that you are performing periodic audits on these base images. The base images need to be minimal in nature and needs to have minimal vulnerabilities in them. Now, we have got our environment in infrastructure as code format. We then need to look at compliance as code. So the compliance rule, depending on what compliance policy you want to follow, PCI DSS, HIPAA, SOX, your own org specific policies, you can write them as code. And these codes can then be leveraged to perform periodic checks whether you are compliant or not. Now, the problem with security, or rather all the security tools, is they would give you hundreds of different reports and you would end up having a report fatigue. You'd not be able to absorb what is given in all of these tools, all of these reports. So you need a different style of presentation. You need a central dashboard which allows you to normalize the data and gives you a high-level overview of what is going on. Plus, it allows you to connect with the bug tracking system, be it Jira, be it Bugzilla, whatever, and allows the devs to work on the items directly in the bug tracking system. Now, this piece of software would be called vulnerability management system. We'll look at it in a few minutes. Now, once everything is checked and we have done security and we have done compliance and everything, we then need to set up alert and monitoring. Monitoring is needed to understand whether the security controls are effective or not, and where do we want to improve. How do you check security controls are effective? Can you track when the attack occurred? Was it blocked or not? What level of access was achieved if it was not blocked? And what was the data that bought in and was bought out? Now, this brings me to an interesting scenario, which is about while we're talking about monitoring, we need to understand we are trying to monitor the assets. Now, the definition of assets have changed rapidly. With the recent advancements, we have a large chunk of our resources up on cloud in a bunch of different places. So the definition of assets has changed from just a laptop or a desktop. So this link that I've mentioned here does a very good job at redefining the assets in a modern perspective. I would request, if you are interested in understanding more on the recent asset classifications, this would be the link that you should be referring to. Now that brings me to a point where we have discussed about various portions of DevSecOps pipeline. This is how a DevSecOps pipeline might look like. This is where we have taken a basic Java application, put it into a DevOps pipeline, and then added security checks all around. So instead of explaining this here, I would quickly go in and play a video which should give you a quick idea. So you can see that same pipeline. There are multiple stages that we are adding in, and these stages are basically the stages that we talked about. So now you can see pre-commit hook, as I talked about, we are going to be using Talisman as a tool. You can see AWS secret key is what it is trying to add. And as soon as you do a git push, you can see that there is an error message saying I can't push it because there's some sort of a base64 or a hex encoded text in the file. So this stops from a blunder happening. Now let's get down to the pipeline. We'll start with software composition analysis. We're using OWASP dependency check at this point. So you can see we have added some code and the dependency check has failed. And here you can see there are 38 high severity vulnerabilities. So we went in, looked at our code, and you can see there are a section that we have commented out. This was the old version of struts that was there. So if you remember recent Java struts based vulnerability, this was the exact version which was there. And Equifax breach was because of this particular struts version. Now you can see the version that we have provided above, which should solve the problem. And now you can see we are in green, although there are 5 high risk items still. However, the condition that we had, these 5 high risks were not directly implementable or not directly exploitable in our environment, and moving anything above than the version that we have provided basically meant a redesign of the entire architecture. Hence, we accepted these 5 risks and moved on. So now the next stage that we have done is the static analysis tool. And for this, we've used find bugs. And you can see there is one high severity vulnerability in this. Now this vulnerability is in our own code, and hence we will go in and fix the code. So we went in, there was a vulnerable function, we worked with it, updated it, and then we are now trying to push it up. As soon as we do a git push, now you can see that one high risk vulnerability is gone because we have fixed the issue. Now comes the DAST stage. Here we are using OWASP ZAP as the scanner. And here is the next interesting bit that you will realize. ZAP or any dynamic scanner can actually take a large amount of time. And we don't have the whole day for the scanner to finish. So what we'll do is we'll run this scan, but we will let the result come in over an email instead of waiting for them to get a response and then we'll move forward. I will immediately get a response whenever the scan finishes on my email ID, and then I can take an action accordingly. But I will not block the pipeline for this. Now, for the infrastructure that we have a couple of images, which is the Docker images. So you can see we are trying to run a clear scan on it. And once the clear scan is done, we are then leveraging OpenVAS as our vulnerability scanning software. and we are performing OpenVAS based scans. Again, OpenVAS scans are going to be exhaustive, and hence I will wait for them over email and I will not block my pipeline. So you can see the scan started, scan finished, and then an email notification came up. Now I talked about compliance. So we are using Tomcat here. We'll use inspect as our tool and we'll perform audit on it. And you can see there are some successful control, there are some unsuccessful control. This was the standard compliance check for Tomcat 8. Now we've integrated a approval based build deployment. So once an approval is given, then the production deployment takes place. In production environment, we have a WAF deployed, and this WAF would basically give us alerts whenever someone tries to attack on our web application. Now, we talked about having large number of reports, massive data. So this is where vulnerability management system comes into picture. What we have is ArcherySec. So we'll use ArcherySec to aggregate all of the data. And you can see it allows you to integrate data from a large number of scanners. And you can get the data, aggregate it, see it in a nice manner. All the projects are marked with their scan IDs. And that kind of gives us an overview of what we have as a sample implementation of DevSecOps pipeline in by improving the DevOps pipeline. And this is an on-prem solution where we are only using open source softwares. So that's not the only tool that can be used. There is a whole large number of tools that can be used. We've tried to give you a list of open source tools here. The idea was not to endorse any commercial tool, but just keep open source tools here. So you can see a bunch of different open source tools around each of these types are available. And you can see more tools under VM category, DAST category, security and infrastructure as code, compliance, and WAF categories. All of these tools are open source or freely available and do not have licensing limitations. We specifically are not endorsing any specific tool, and we are not even mentioning proprietary tools in this because we wanted to keep it open source only. But now, with all these tools at hand, how do you decide what tool to use, what to not use? This is where you need to look at following parameters. The API should be present, or the tool should have a command line access. The start to finish of the execution should be less than 15 minutes. If it is more than 15 minutes, you'll have to go the similar route what we did for Zap and OpenVAS. The ideal number is 15, but there's no restriction that it has to be 15. It could be 5, it could be 10. The idea is minimal change in the DevOps pipeline and you get your task done. Which means the tool needs to be scriptable or containerized because you're not going to do it manually. Should not have licensing limitations. This is a very, very big problem when it comes to proprietary softwares. Let's say you have a license to scan 100 web applications. The way they detect the web application is by looking at the URL. And let's say you're doing production and QA deployments, or rather, let's say QA deployments with random names. And if you did even 20 builds a day, within 5 days, your 100 application scan of a year is out and you can't do anything about it. So licensing limitation, keep a check on that. The output should be in a parsable format. No standard output, no JSON, no standard output, but definitely JSON or XML is preferred. But just standard output or standard error is not the right approach. You cannot parse that output clearly. So prefer machine readable formats like JSON or XML. You need to have the configurability in such a way that you can mark false negatives and false positives. Now, again, we are still talking about pipeline. Pipeline again can be optimized. You can tweak the pipeline for different angles. Like for example, if there's a change which only has CSS in it changed, you don't need to run most of the tools. If pom.xml or Gradle script has changed, SAST is not required. SCA was the only thing that was required. If there is no change in infrastructure as code, you can maybe just fast track infrastructure scan. However, if you optimize these pipelines, you need to keep one full-blown pipeline and run it periodically. Now, another question that generally I've heard people talking about is, does the language matter? What if I've written a tool in PHP or Python or .NET? How does it differ? So important thing to remember is the only difference that will come up is in the static analysis and software composition analysis section pertaining to different languages. Some tools support multiple languages, others are focused on one specific language. So this is kind of a list of SCAs and SAST tools. And you can see there's a whole large array of options. All of them are open source or freely available. Like I said, we are not going to endorse private entities or rather proprietary entities. So like I said, the only change that you will find is in the two stages, the dependency check and the SAST. And you can see for Ruby, we just need bundler auditor and brakeman. For PHP, we need SensioLab security check and PHP CS. For Python, we have safety and bandit. For Node.js, npm check, Node.js scan. So you can see for each of these models, only the two softwares changed and we have a fully working DevSecOps Lab. Which brings me to the next part, which is, what about cloud? Cloud is an integral part when we talk about DevSecOps. With cloud versus on-prem, the major change that happens in the identity and access management area, the asset inventory, and the billing. Now, it's not all bad. There are a large number of good things also. Because you're already in infrastructure as code format, it might actually be more easy to audit and find flaws. The focus area when you're looking at cloud needs to be on security groups, permissions to resources, rogue and shadow admins, or forgotten resources. These are going to be the major challenging problems for you. I've mentioned 3 tools on the side: CS Suite, Scout Suite, Security Monkey. CS Suite and Scout Suite are like Swiss Army knives. They allow you to inspect code of, or rather inspect the environment of AWS, Azure, and GCP. Whereas Security Monkey is basically an active monitoring solution which you install within your environment. And if it finds any change, it will come up and inform you that, hey, something changed. This particular port should not have been open, or this particular group should have been in a much tighter permission model. All of that, Security Monkey is going to give you an alert. Now, what changes when you're trying to do DevSecOps in a cloud native environment? So a large array of tools are already provided by the cloud service provider. Only the following 4, static analysis, dynamic analysis, software composition, vulnerability management, is not provided by the vendor, and we need to work on getting them in. So what we've done is we've given you a sample implementation of cloud native DevSecOps. Here you can see there's a whole bunch of tools that are going around. So let me quickly play a video outlining DevSecOps implementation in a fully cloud native environment. So here you can see the same environment that we talked about, and we have various stages available inside it. Stage 1, pre-commit hook, again, the same talisman thing. We are using the exact same software, so the exact same issues would come up. And now you can see we've added the vulnerable version of struts. As soon as we do a code build, the build gets successful and it gets outputted. This is the standard DevOps process. Whereas now if we add source code analysis, software composition analysis checks, the first action item, it fails. And here you can see there are 38 high severity vulnerabilities. Again, we're going to go and fix by putting in the proper version numbers, and you can see the vulnerability count is down to 5. Again, for SAST, we'll have 1 high severity. We go in, patch that, and move forward from there. So you can see for ZAP, we are running the scan with We're using the cloud environment to run the environment, to basically build the environment, run the scan, and push the scan back into uh, ArcherySec for further processing. Now for vulnerability assessment, we're using Amazon Inspector, and you can see that it has already identified a particular vulnerability. And here you can see the instance is vulnerable to a CVE, and you've gotten the details about that CVE. Now stage 5 is around compliance. Again, you can run compliance scan. For monitoring and alerting, we've used the Amazon native environments. Here what we've done is we are trying to identify how an SSH attack happened, SSH brute force attack happened. So we're leveraging guard duty. We're trying to see what happened and where, and you can see there was a SSH brute force attack that was performed. Now let's see if password authentication is actually enabled or not. And you can see the instance that we had password authentication enabled over the network. So that needed to be properly weeded out. And here you can see if a valid login happened, it would look something different. These are all invalid login attempts, whereas these are valid login attempts. So in the logs, you can actually see a difference. Now we're using Amazon Macy to alert for S3. This is recently changed. Now Amazon itself is doing a check where they are informing you as soon as they find an open public bucket. So you would get periodic reminders that yes, the bucket is open and you should not be keeping the bucket open. So you can see this bucket was public in nature, and that is what was caused. Now within Macy, you have a bunch of different stats available. You can get as many alerts as possible. Now what we've done here is we've kept ArcherySec as a Lambda function, and within that Lambda function, again, we are importing all of the files and doing a bunch of checks and aggregating all of the data. So again, this is how the simple scenario of a AWS cloud looks like once DevSecOps is implemented. All right, let's get back to the slide deck. So what changed for each of the three major service providers, AWS, Azure, and GCP? I've compared them with the conventional infra that we used to use, and what is the equivalent infrastructure element that we should be looking at if we are looking at any of these cloud service providers. Now that brings me to the point about cultural aspects. Now automation alone is not going to solve the problems. We need to encourage security mindset, especially for people who are not part of security. Now what I've generally seen is, if you look at the photograph at the side, this is what is general assumption. The DevOps is pooping rainbows and security is just cleaning the mess up. If that's the mindset that you want to go in, you will not be able to do anything. The idea in DevSecOps is the security team should try to eliminate the need of a dedicated security team. You should not have a dedicated separate security team, but rather everyone within the team should be security conscious. So you need to focus on collaboration, inclusive culture. You need to build allies, and you need to avoid the blame game. Problems happen, issues do happen. You should focus on why that happened. It's just not a person-centric issue. And how can you detect this within the pipeline before it hits the production environment? So the important ingredient for all of this is the security champion. This is the person who would basically be bridge between DevSec and Ops team. Could be one person per team, could be the entire team. You can try cross-skilling them, or you can try to incentivize the other teams. A couple of incentives methods that I found working is sponsor interactions, sponsor parties, get-togethers, whatever. Sponsor internal bug bounties. So teach your developers how to do bug bounties, how to find bugs, and then let them find bugs in their own codes. Sponsor cross-skilling trainings. So if a developer one day comes up and says, hey, I want to learn secure code development, however, my team does not have the budget for it, the security team should be more than happy to foot the bill, because ultimately they would learn that skill set, come back, teach others, and if not teach others, at least one less person to worry about, or one person where you can trust they would probably try to do a better job at writing secure code. Now, just like everyone talks about people, process, and technology, so security enablers in the form of people, process, and technology is what you can see here. From a people standpoint, focus on solutions, empower the dev and ops instead of blocking them, and nurture as many people as possible. From a process standpoint, fix by priority. Do not attempt to fix it all. You can see there are situations in pipeline where we left some high severity flaws because we didn't want it to fix them right now. They were not on the high priority. Now, from a technology standpoint, you need to templatize as much of stuff as possible, and you need to keep out for simpler and better options. And whenever you find something more useful than what you have already, you switch to that. Which brings me to a standard case study that you can think of. So in this scenario, this is the DevOps flow. We started somewhere in May, mid-May, Struts vulnerability came in, but it will not be spotted till June, because June is when the first scan is going to happen. Now compare this with the DevSecOps cycle. As soon as the vulnerability is introduced, within 2-3 days, as soon as the SCA is updated, it'll be flagged and will be fixed. So by the time next session happens, this is already fixed and gone from the memories. Now, DevSecOps case studies are hard to find. So I've got 2 case studies where they've gone in public and talked about what they've done. So this is Fannie Mae, and you can see run as one security and DevOps as a single team. They've done some training program. They've empowered the developers. They're tracking security issues in the same system as developers, and they're trying to automate as many tools as possible. This was the performance improvement. The average days to close a security flaw fell down to maybe less than 10 or 15 days, whereas it used to be way, way high initially. Again, you can look at the details on the link that I mentioned below. This is IDE Amro. Again, you can see build process has a bunch of different security checks added in. And this is how IDE Amro has gone in and deployed DevSecOps or security in the DevOps environment. This was the advantage. They had 20% successful build, 75% less test timings. They had minus 100% bogus package creation, and they had a bunch of other improvements. That brings me to a negative case study. These are the list of S3 buckets which had public data exposed. If we were continuously monitoring and reviewing the cloud assets, if you remember, SecurityMonkey is one thing that can actually do this job for you. That would have prevented this. Now, is it enough? Whatever I talked about, I preached DevOps and DevSecOps like a silver bullet, but let's be honest, let's be practical, it's not silver bullet. You will still have to do periodic pen tests and continuous bug bounties if possible, because the idea is you've deployed a pipeline, there will be flaws, there will be problems. You need to have a way in for a feedback mechanism. Periodic pen test and continuous bug bounty are those methods. The 5 images that you see at the bottom, these are 5 firms who basically call themselves the champions when it comes to DevSecOps. All 5 of them offer bug bounties. So that should be one way to think about. Now, as an administrator, ensure that you're not relying too much on risk acceptance document. Should be focusing on solving the issue rather than relying on RAD or risk acceptance document. Which brings me to an interesting point, which is who watches the watcher? It'll not make any sense if you have all of these awesome security controls and your vulnerability managers credentials are admin. So don't be an hypocrite. As a security team, if you're deploying security softwares, ensure you run security checks on your own security softwares. Follow secure configurations, follow patching policies. That's the least we can do when it comes to deploying your own DevSecOps environment. Now, these are a couple of references that I've used throughout the slide deck. I've talked a lot, but if you have to take 3 key takeaways from this talk, this is what I would suggest as the 3 key takeaways. Security is everyone's responsibility. You need to embrace security as an integral part of the process and use feedback to refine the process. Now, DevSecOps is not going to be a one-size-fits-all program. Do you remember there's a saying, your mileage may vary, and people keep saying that. However, with DevSecOps, your mileage will most definitely vary because every organization is different. Every organization can have different ideas, different ways of doing it, and that would basically add up lots and lots of variations in the DevSecOps process.